Very good morning to all person here. This is Anand. I'm working as assistant professor in the Department of Mechatronics Engineering in past 10 years. So I'm handling electrical drives and control subject for the mechatronics engineering students. Today we are going to discuss about the topic of the stepper motor. This is a three session lecture series. The session going to discuss about the working principle of stepper motors and what are the types having in stepper motor, and then advantages, application, and drawbacks or limitations. So starting from what is stepper motor, the definition of the stepper motor is a special type motor. It's not a comes under the AC motor or DC motor. It comes under the special type motor. The stepper motor or step motor is brushless synchronous motor which divides a full rotation into a number of steps. Normally the motor having continuous rotation in 360 degree, but coming to the stepper motor, the motor rotates in step by step angle. Unlike the brushless DC motor which rotates continuously when a fixed DC voltage is applied to it, a stepper motor rotates in discrete stepped angles. Based on we have 360 degree angle, it was separated with a 30 degree, 15 or 5. Likewise, stepper motor therefore are manufactured with the steps per revolutions of 12, 24, 72, 144, 180 and 200, in resulting in stepping angle of 30, 15, 5, 2.5, 2 or sometimes 1.5 degree per steps. This is I think this is the very minimal degree step angle in our day-to life. The step motor can be controlled with or without feedback. For example, some of the motor based for example, BLDC or reluctance motor having a feedback. The motor cannot run without feedback. Likewise, the stepper motor having the feedback, as well as the motor can run without feedback also. This is the cross-sectional view of stepper motor. We have a single connecting shaft connect the stator and rotor. The basic principle of simple structure of the motor is stator rotor. Here stator is a normal iron laminated core. Here rotor is magnet. But whereas coming to the AC or DC motor, it is not a magnet, it is iron lamination core. But here we are using magnet as a rotor. Here rotor section, and then iron laminated core stator, and then rear end cap windings. But in rotor side there is no winding, but coming to the stator, it has winding sections, and then bearing, shaft, front end cap. This is a simple cross-sectional view of stepper motor. And then coming to the working, what is the basic principle of stepper motor? So coming to the AC, it is a electromagnetic induction principle. Coming to the DC, it is Fleming left-hand rule as well as Faraday's law. So both working principles coming together and used in working of DC motor. But coming to the stepper motor, working the principle of electromechanic principle. What is electromechanical principle? Basically, what is mechanical principle? It is magnetic attraction and magnetic repulsion. This is the basic structure of electromechanical principle. There is a soft iron or magnetic rotor shaft surrounded by the electromagnetic stator. The rotor and stator have poles which may be tethered or not depending upon the types of stepper. When the stators are energized, the rotor moves to align itself along with the stator. In case of permanent magnet type stepper motor, or moves to have a minimum gap with the stator in case of variable reluctance motor. So this way the stator are energized in sequence to rotate the stepper motor. So and then overview. So this is a side cross view, and then this is the rotor So here in stator side we are having uh, coil windings for each and every slots. Coming to the rotor, there is no coil, there is no slots, only steps angles, that is rotor poles connected with the shaft bearing magnetic shafts. So and then